What should I write up here?
Quadrilaterals. Quadrilaterals.
Do you guys know what a quadrilateral is?
It's a closed
It's a polygon
geometric figure with four sides and four vertices.
with, okay, four sides
I made it.
and four vertices. Can I give me an example of a quadrilateral? Square. You guys know what makes something a square? It has four right angles and four congruent sides. Example would be a square. Very good. Okay. What do you think? Tell me what's at each of these four vertices. Where are the vertices here? In the example I drew here, my square, where are the vertices? The corners. So there are A's of vertices, B's of vertices, C's of vertices, and D's of vertices. In a polygon, a vertices is where it basically changes direction, a corner. Okay? What do you see at each of these corners? What are they called? At each of the vertices, there is a what? There's an angle at each of them, isn't there? So a quadrilateral is going to have four sides and four angles, is it not? Interior angles. Okay. Now, mostly we've dealt with a lot of triangles, so you haven't had to deal with this. So let's like the book does here, we're going to draw kind of our own bigger quadrilateral here and just talk about it. So I need four sides, so I'll make one side like that. Let's see, I can make one side, it needs to change direction, so I can make one side like that. Now that would be a what, if I connected them? Okay, so I need a fourth side, so how about I go like this? And then how about I just connect the dots there? Now how many sides does that have? Four. And you name a quadrilateral by naming its vertices in consecutive order. In other words, I could name this, when I mean consecutive orders, how do you think you could name this this quadrilateral? Huh? I could name it A, B, C, D. Somebody give me another name. A, D, C, B. Yes. D, A, nope. Has to be consecutive vertices. T, A, D, A, B, C. So what do you think I mean by consecutive? If I was walking along the outside of this, the next consecutive vertices to D would be what? Or consecutive vertices to B would be what? Or C. Okay, now, so there's four sides, four vertices, four what? Angles. Now, this is something that's called a special side. Does anybody know what these are called? Well, if this was a street corner and this was a street corner and you walked from here to here, how are you walking?
Diagonal.
Diagonally, right? You know what this is called? A diagonal. Diagonals connect two non-consecutive vertices. So how many diagonals do you think there are here? Is that the only diagonal I could draw? What's the other one? A to C. We'll talk about diagonals a lot with quadrilaterals. We'll have certain types of quadrilaterals. We'll have the diagonals have certain properties. So how many diagonals are there? Two what? That all makes sense? Little review here. In a triangle, equal what? Huh? I didn't hear what? 180 degrees, everyone agree with that? You guys remember that the angles inside a triangle have to add to 180 degrees? Let's talk about a quadrilateral. What do you think they have to equal here? And you are correct. They equal 360 degrees. Pretty easy concept, isn't it? And that's pretty much all there is to this section. So we need to get our worksheets out. You guys are done writing that down. We'll talk about it. Let me know when everybody's got that down. Let me see your pencils down or whatever to kind of let me know that I can unfreeze it. How we doing? Everybody got this down? Almost? All right, we ready? Yes. Okay, looking at number one. Name a side that is consecutive with JK. Well, we didn't talk about consecutive sides, but do you think they'd be the same as consecutive vertices? This is J to K, correct? What side is consecutive to it? Well, that would probably still be the next side you'd get to. Which side would be opposite JK, do you think? It's funny how opposite makes more sense to us than next to or consecutive. So, what would be a side consecutive to KL? JM? Or what could you have said? And how do I need to just write JM or do I need to put a segment line above it? I do need to put that above it, don't I? Don't just write JM. That's wrong. That's the distance from J to M. Name the side opposite KL. Well, we already talked about that. That's what? ML. Name a vertex that is opposite L. There's only one answer here, isn't there? What is it? What? Oh, it said KL, didn't it? I assume I read it wrong, didn't I? Thank you. What is opposite KL? Very good. Well, what is opposite L? Name a pair of consecutive vertices. Only need one pair. Can anybody tell me? JK? J and K. You could have said K and L. You could have said L and M. You could have said M and L, right? Name an angle opposite angle K. I think we got the verbiage down there, don't we? What do you think they're going to have you do? Find the missing measure. What do we know about all of these? What do they add up to? So what I want to see on your papers to show me that you understand this concept, I want to see this. I know you could do this in your head. What I want to see is if you can write it down. It's not that long to write. What do all these have to add to? X plus what?
7,
Huh? 88 plus what?
107,
Plus what?
97,
Should all equal what?
180. Or wait,
360. What are these added together? Someone put on their calculator 88 plus 107 plus 97 for me, please. Huh? Say it again. What am I to do next? X is equal to what? Can we all do that? It's not too much to ask, is it? Doesn't take that much to prove to me that you're doing the work and you know how to solve an equation. That's what I expect.